Here is a regular hexagon. Join 3 of the dots to make an equilateral triangle. So a hexagon is a 6-sided shape, and the word regular tells us that all of these lengths are the same size. Now we need to join 3 of the dots to make an equilateral triangle. So that's a triangle where all of the sides are the same length. So we could join these 3 dots here, because then all of our sides are the same length. Because notice, between these 2 points we have a dot, between these 2 points we have a dot, and between these 2 points we have a dot as well. So this tells us that our lines are equally spaced. Or we could join these dots here, or these dots here. Here is a shaded shape on a square grid. Draw the reflection of the shape in the mirror line. So we can see that we have a diagonal mirror line, and diagonal mirror lines are confusing, but what we can do is turn our page so that we have a vertical mirror line. And then remember, when we need to draw the reflection, we need the same reflected on both sides. So we need to shade this square here, because that's the other side of the mirror line to this square here. For this square here, to reflect it, we can see that we go through half a square. So from the mirror line, we go through half a square and shade this square. And then this square here can be reflected in this square here. And then we need to shade this triangle as well, so that we've reflected our shape in the mirror line. A shop sells pairs of socks. Kirsty buys 1 pair of knee socks and 3 pairs of ankle socks. She pays with a £20 note. How much change does she get? Well, first, let's work out how much she spends altogether. She buys 1 pair of knee socks, so 1 pair of knee socks is £5.45, and 3 pairs of ankle socks is £7.50. So if we add those together, that gives us £12.95. To find how much change she gets, we can take what she pays with and subtract the value of what she's bought. And when we do that, remember, £20, we can put 0.00 on the end, and then we can use column subtraction, and that gives us £7.05. So that's how much change she gets. Now, Amy spends £25.50 on trainer socks. How many pairs of trainer socks does she get? We're told that 5 pairs cost £8.50. So that means 10 pairs must cost £8.50 times 2, or £8.50 plus £8.50, and that gives us £17. Now to find 15 pairs, we can add what we got for 5 pairs to what we got for 10 pairs, and £8.50 plus £17 is £25.50, and that's how much she spent. So we know that she must have bought 15 pairs of trainer socks. Some children do a sponsored walk. The graph shows their results. How many children walked 21 laps or more? So we have the number of laps walked on the bottom of our bar chart, and we can see that this bar here shows how many walked between 21 and 25 laps, and if we go to the top of the bar and draw a line across, we can see that that's 13 children. But we also need to look at this bar here, because this bar tells us how many walked between 26 and 30 laps, and that's still more than 21. So if we go to the top of this bar, we can see that this bar here is 10 children. So to work out how many walked 21 or more, we need to add 13 and 10, and that gives us 23. So our answer is 23 children. Ben's rectangle is 10 centimetres long. It has a perimeter of 28 centimetres. How wide is his rectangle? So the perimeter is the distance or length around the outside of a shape. Now we know that with rectangles, opposite sides are the same length. So if this length here is 10, then this length at the top will be 10 as well. So we could solve this with a bar model, or we could try something else. We know that the two lengths, so 10 plus 10, plus the two widths must equal 28, because that's the perimeter. So I've written 2w to stand for the two widths, so this width here and this width here. Now 10 plus 10 is 20, so 20 centimetres plus the two widths together need to make 28 centimetres. That means the two widths together must be 8 centimetres, because 20 plus 8 is 28. And if the two widths together are 8, so if this width plus this width is 8 centimetres, then each width must be 4 centimetres, because 8 divided by 2 is 4. So the width of the rectangle is 4 centimetres. John says every multiple of 5 ends in 5. Is he correct? Explain how you know. So here we need to know what a multiple of a number is. Now remember, a multiple of a number is any number in that number's times table. So if you divide a multiple by the number, you won't get a remainder. So John is not correct. Numbers that end in 0, for example 10 or 20, are also multiples of 5, because 10 and 20 are in the 5 times table. It's not just numbers that end in 5. So if what they've said is wrong, for explain how you know questions, you can just give an example. So here you could write 10 is a multiple of 5, but it doesn't end in 5, so John is not correct. This plan of a garden is made of rectangles and triangles. The area of each rectangle is 12 square meters. What is the area of the whole garden? So we know that the area of each of our rectangles is 12. And here we need to spot that the area of a triangle, so remember the area is how much space a shape takes up, the area of the triangles will be half the area of the rectangles, because if we split a rectangle in half, we get something the same size as these triangles, and half of 12 is 6, so the area of the triangles will be 6. But we need the area of the whole garden. So we have 5 rectangles which are each 12 meters squared, so that's 60 meters squared just for the rectangles. But we also have 4 triangles, and the area of each triangle is 6 meters squared, because the triangles are half the size of the rectangles, and 4 times 6 is 24. So if we add up the total area for our rectangles and our triangles, we get 84. So the area of the whole garden is 84 meters squared. Match each decimal number to its equivalent fraction. One has been done for you. So they've told us that 3/4 is equivalent or has the same value as 0.75. So what we can do to match up our decimals and our fractions is to change our fractions into decimals. And 2/10 is 0.2, because remember with decimals, the first digit after the decimal point always tells us how many tenths we have. But now we have 1/4, and there isn't a decimal place value for quarters. So what we need to do is to change our 1/4 into hundredths, because the hundredths place value is the second digit after the decimal point. We can't change 1/4 into tenths because 10 is not in the 4 times table. But if we multiply 4 by 25, we do get 100, and so we can do the same to the numerator, and we found that 1/4 is the same as 25 hundredths, so that's 0.25. The hundredth digit is the second digit after the decimal point, which means that the 2 gets pushed over into the tenths. So 1/4 is 0.25. Now we need an equivalent fraction for 2/5, and 10 is in the 5 times table, so we can find an equivalent fraction to 2/5 with a denominator of 10. Again, we use multiplication, and we can see that that's the same as 4/10, so 2/5 is the same as 0.4 because the 4 after the decimal point tells us that we have 4/10.